mean, you're going to have that problem whether you've built or not, actually. If there isn't the capacity for the water to drain at a certain location because of the water table, then that's always going to be the case. In fact, that can be an advantage sometimes if you've got a high water table, where you can, once you've built, you can actually remove water from that area and move it to somewhere where the water table's lower. You may actually reduce the risk of flooding by removing water from the site.
So what sort of retention and attenuation techniques could we talk about?
Well, we can use infiltration trenches, filter drains, swells and basins.
Well, this is, so that's like, I mean, the ditches, effectively, yeah?
Yes, architecturally, aesthetically.
Yeah, swale is a nicer word. But are we talking about holding tanks as well?
Well, underground, there could be, were covered and made retention tanks underground.
So what if, as an example, say you had a patch of land and your house, the footprint of your house took up that entire land, where you don't then have, presumably, the opportunity to use swales and infiltration ditches?
Well, theoretically, yes, but then does not forget that it's a management train. So there are many stages. It's like it's part of a design process. So if we are limited in the area where we can place retention tanks, then we can go back to the prevention, where we should pay more attention to the prevention stage, where we should try and minimize the discharge of water runoff altogether.
I'm not sure that that's always the case, because sometimes it seems to me that it would make more sense to remove water from one area, you know, rationally choosing to take it somewhere else and deal with it elsewhere. Especially, you know, if you've got a large housing estate, trying to deal with it on site can actually be terribly problematic. Whereas removing it, you know, moving it away from where the buildings are and so on, and dealing with a large amount of water at one time can sometimes be a better approach. The code suggests that that should always be done, you know, at that particular location. What I'm arguing is that actually thinking about what's the best location to treat water and to store water and to slow flow should be thought of in a much more holistic way. You know, there's an assumption that everything has to be local, and I think that's a faulty assumption.
Well,
defend your case, Costa.
Yeah, but you said for a housing estate, but
as an example.
As an example. But then again, to take it somewhere remotely, you have to spend energy and spend more money in infrastructure. So then again, you win some, you lose some.
You do. I mean, actually, I think there's a lot to be said for being ambitious about infrastructure. I mean, it's something that's out of favour today, but actually, if you look at the history of removing water from sites, you know, the pipe water network that we have, the drainage systems that we have historically, I mean, that was a massive boon to our civilization and to this country. You know, it's what enabled the cities that we have to exist.
There you go, answer that. The great civilization drive of hydroengineering. But I'm afraid I'm going to bring you back to the crass realities of the Code for Sustainable Homes and come back to you, Costa. It says there's one credit available if after 5 millimetres of rain there is no discharge off-site. So if you took a typical house, what sort of volumes are we talking about? But also, what do you have to do then to prevent that discharge?
Well, approximately we're talking about 15 litres per second. A volume flow rate of around 50 litres per second.
Okay.
But in order to prevent that, we can use green roofs, rainwater harvesting, and permeable pavements, which, for example, rainwater harvesting, we can reuse the water for toilet flushing or to water the garden, and permeable pavements, they provide infiltration, and then so the rainwater returns back to the soil. And for the green roofs, apart from providing insulation, they provide filtering of the water, so, and they also help in the biodiversity.
Okay, so the example I gave previously about a house which took up the entire